All right, we'll continue on with our applications on implicit differentiation. And we're looking next at some vocabulary. We're finding the equation of not only a tangent line, but also a normal line to a circle at given points. So little vocabulary, the normal line at a point is perpendicular to the tangent line. So the normal line is perpendicular to the tangent line. Now, I've gone ahead and given you a picture of where we're going to end up, but keep in mind that really all we have to start with is the circle. So we have x squared plus y squared equals 9. And remember, that would be a circle centered at 0, 0 with a radius of 3. We're supposed to find the normal line and the tangent line equations at 2 points. So we're going to first concentrate on the point 0, 3. So we'll find the derivative implicitly. That's fairly easy to do. So taking our original equation, we'll do the derivative of the x squared, that would be 2x. We'll do the derivative of the y squared, that will be 2y, but because it's a y, we have dy dx, and then the derivative of the constant, which is 0. Then we'll get the dy dx by itself, so subtracting 2x to the other side, and then dividing by 2y, you get your slope, which is dy dx, and that simplifies to negative x over y. So that's our slope formula. And then we can substitute in our ordered pair. So notice that 0 is x and 3 is y. We'll substitute those in, and we get a slope of negative 0, which there's no such thing. So it's just 0 over 3. So again, that came from this point being substituted in for the x and the y to get 0 over 3. And so the slope of our tangent line is 0. And then I'll scroll up just a little bit here. And now we're going to find the equation of the tangent line. And so you can do your y equals mx plus b, but you actually have the y-intercept of 0, 3, and your slope was a 0. So y equals 0x plus 3 is going to give you the horizontal line, y equals 3. And that's how we would know that this is the equation of the tangent line, y equals 3. So then you're asked to find the equation of the normal line. Well, the normal line is perpendicular to the tangent line. So that means that if our slope is 0, or I'm going to start us off looking here, 0 over 3, then our perpendicular slope is going to be opposite sign and flipped over. Now, opposite sign of 0, there is no opposite sign, but you can flip it over. And 0 over 3 flipped over is 3 over 0. The reciprocal is 3 over 0. And that means that we have an undefined slope, which shouldn't really be too big of a surprise, because if your tangent line is horizontal, then the line that is perpendicular to that would be vertical. And so as we continue to look at part C asks you the equation of the normal line, or the perpendicular. So that has an undefined slope that told us that it was vertical, and vertical lines have the equation of x equals whatever the x is in your ordered pair. So x equals 0 from the ordered pair. So now I'm going to go back to my graph and get my line lined up. That was my tangent line. So now I have my normal line at 0, 3 being vertical and going through 0, 0. So this is the normal line, and its equation is x equals 0. And so we've accomplished finding the tangent line equation and the normal line equation through 0, 3. But we have another part to do on this. Now we have to do the same process and find the tangent line equation and the normal line equation through the other ordered pair, which is 2 and the square root of 5. And I want to point out that 2 square root 5 is on the circle. 2 squared plus the square root of 5 squared would give you 9, because that would be 4 plus 5. So 2 square root 5 is on the circle. And so I'm going to scroll to where you can see that work. And I actually have the circle redrawn. So we've already done the derivative. We don't need to do the derivative again. We just need to apply it. So the derivative was negative x over y. Here's your x and your y. So substituting in, your slope would be negative 2 over the square root 5. And I just rationalize the denominator to make it negative 2 square root 5 over 5. So that's the slope of the tangent line. And then my work to find the equation of the tangent line is in this area right here. So I substituted in from my ordered pair, here's the y, and then here's my slope, negative 2 square root 5 over 5, and my x, that's the 2, and then plus b. So I'm looking for b. I can multiply together my 2 and my negative 2 square root 5 over 5, and then add to the other side. So b, although kind of weird, is 5 square root 5 over 5 plus 4 square root 5 over 5, because I had to get a common denominator. So that's how I did that. I got a common denominator to give me 9 square root 5 over 5. So my equation, I'm going to clear the ink so we can focus on it. My equation of the tangent line is y equals negative 2 square root 5 over 5x plus 9 square root 5 over 5. So when x is 2, so let's say x is 2 right there, your y is the square root of 5. That was my ordered pair, 2 square root 5, and this is my tangent line, and I now know its equation. So the tangent line equation, and then we have to find the normal line. So the normal line for this, I have to do the reciprocal of my slope, opposite reciprocal. So here's my original slope, and so I'll flip it over and change the sign. And so you'll notice that there's my perpendicular slope, square root 5 over 2. That's opposite reciprocal to the one that I started with. And then as I scroll up and take a look at the y equals mx plus b, here is the work for that. So substituting in the y value of square root 5 for my ordered pair, here's my perpendicular slope, here's my x, and notice that the 2's cancel. I can minus a square root 5 from both sides. My b turns out to be 0. So my equation of my my normal line is y equals the square root of 5 over 2 times x. And so scrolling back up so you can see what it is that you found, the normal line then is perpendicular, runs perpendicular to the tangent line through the point of 2 square root 5. So you have a perpendicular line, and its equation is y equals the square root of 5 over 2 times x. So there's your second example. Again, you're finding lines that are perpendicular to each other, one being a tangent and the other perpendicular to that tangent, called a normal line.